Hello, in this video we're going to look at the Nobel Prize in Physics in 1904, given to John W. Strutt, also known as Rayleigh, for his investigation of the densities of the most important gases and for his discovery of argon in connection with these studies. Information is always gotten from the official Nobel Prize site, and we first start with some relative important quotes from his work. The air consists of several different gases, mostly nitrogen gas and oxygen. Lord Rayleigh developed methods for studying the physical properties of these gases in the atmosphere. When he compared nitrogen extracted from the air with nitrogen extracted from chemical compounds, he found that the nitrogen from air was heavier. He concluded that the air must contain another previously unknown substance. In 1894, he, along with William Ramsay, succeeded in extracting the previously unknown element called argon in pure form and analyzing its properties. Okay, then we go to some information about his biography. Throughout his infancy and youth, he was of frail physique. His education was repeatedly interrupted by ill health, and his projects of attaining maturity appeared precarious. After a short spell at Eton at the age of 10, mainly spent in the school sanatorium, 3 years in a private school in Wimbledon, and another short stay at Harrow, he finally spent 4 years with Reverend George Townsend Warner, 1857, who took pupil Torquay. In 1861, he entered Trinity College, Cambridge, where he commenced reading mathematics, not at first equal in attainment to the best of his contemporaries, but his exceptional ability soon enabled him to overtake his competitors. He graduated in mathematical tripos in 1865 as senior wrangler and Smith's prizeman. In 1866, he obtained a fellowship at the Trinity, which he held until 1871, the year of his marriage. Here you see him. A severe attack of rheumatic fever in 1872 made him spend the winter in Egypt and Greece. Shortly after his return, his father died, 73, and he succeeded to the barony, taking up residence in the family seat, turning place at Witham, Essex. He now himself found himself compelled to devote part of his time to the management of his estate of 7,000 acres. The combination of general scientific knowledge and acumen was acquired knowledge of agriculture made his practice in estate management in many respects in advance of his time. Nevertheless, in 1876 he left the entire management of the land to his younger brother. From then on he could devote his full time to science again. In 1879 he was appointed to follow James Clerk Maxwell as professor of experimental physics and head of the Cavendish Laboratory at Cambridge. In 1884 he left Cambridge to continue his experimental work at his country seat at Tilling, Essex, and from 1887 to 1905 he was professor at natural philosophy in the Royal Institute of Great Britain, being successor of Tyndall. He served for 6 years as president of the Government Committee on Explosives, and from 1896 to 1919 he was scientific advisor to Trinity House. He was Lord Lieutenant of Essex from 1892 to 1901. Lord Rayleigh's first researches were mainly mathematical concerning optics and vibrating systems, but his later work ranged over almost the whole field of physics, covering sound, wave theory, color vision, electrodynamics, electromagnetism, light scattering, flow analytics, hydrodynamics, density of gas, viscosity, capillarity, elasticity, and photography. His patient and delicate experiments led to the establishment of standards of resistance, current, and electromotive force, and his later work was concentrated on electric and magnetic problems. Here you see one of his main researches on gas, in this case the noble gas argon, which he discovered. Lord Rayleigh was an excellent instructor, and under his active supervision, a system of practical instruction in experimental physics was devised at Cambridge, developing from a class of 5 or 6 students to an advanced school of some 70 experimental physicists. His theory of sound was published in 2 volumes during 1877-1878, and his other extensive studies reported in his scientific papers, which consists of 6 volumes issued during 1889 to 1920. He also contributed to the Encyclopedia Britannica. He had a defined sense of literary style. Every paper he wrote, even on the most abstruse subject, is a model of clearness and simplicity of diction. The 446 papers reprinted in his collector's works show his capacity for understanding everything just a little more deeply than everybody else. So this is a summary of quotes from the biological section from the Nobel Prize official site. Here again we see a more modern situation in which argon is used. Then we go to the award ceremony speech by Professor G.H. Cederblom, delivered when Rod Rayleigh got the prize. Among the problems in physical-chemical science that have more especially taken up the attention of scientists, the nature and composition of atmospheric air has always held a prominent position. For centuries, this problem has been the object of both keen inquiry and extensive experimental investigation. Consequently, its history affords a very striking picture of the gradual development of those sciences in entirely closely connected as it was with the progress made in the various departments of physics and chemistry. The retarded influence which in former times was continuously excited not only by incorrect opinions that had become firmly established, but also by efficient experimental groundwork, is plainly observable, and it explains the fact that during the 17th century the solution of the problem was not and could not be arrived at such by scientists as Boyle, Marlow, and Hales. It was only obtained 100 years later, after the discoveries of Priestley, Black, Cavendish, and above Lavoisier, in a manner which not only then, but up to quite recent date was considered final. Under such circumstances, it is not but natural that the discovery of a new component of the air, one that is present to the considerable amount of about 1%, excited great and justifiable astonishment. How was it possible, people asked, that in the face of all the improvements in both physical and chemical methods of observation of the present day, this dash could for so long have remained unobserved? The answer to this question not only lies in the strange indifference to chemical investigations by the age is characteristics, but also in the investigations on the physical properties of atmospheric gases not having then reached that high degree of accuracy which Rod Rayleigh has since succeeded in attaining. This is especially the case in determining densities. It has been known that nitrogen, when separated from air, is invariably heavier than when produced from its chemical components. As the difference is not no less than 0.5%, there's no doubt as to the existence of these differences, since the accuracy of the weigher has such that the possible fault could only be 1/50th thereof. Here, by the way, we see argon contained in cylinders. Since between those two kinds of nitrogen, on the one hand atmospheric, on the other hand that obtained from chemical components, there is a definite difference in density. The question arose, what could be the cause of this peculiar state of things? All the circumstances of the investigation which might be supposed to have any influence in this respect have been carefully examined, and their influence being found insufficient to explain the difference observed. There remained, in Lord Rayleigh's opinion, but one possibility, that the atmospheric nitrogen was not a simple element, but was a combination of pure nitrogen and some new, hetero, unknown, heavier gas. If so, this gas could be isolated in some way or the other. The methods, physical or chemical, available for the solution were already known in principle, and the problem now was to obtain the new gas not only in the purest form, but also in a sufficient quantity to allow a thorough investigation of its essential properties. These both difficult and tedious tests have been carried out conjointly by Lord Rayleigh and Sir William Ramsay, and have resulted not only in completely proving that the new gas occurs in a ready state in the air, but also in establishing a thorough knowledge of its chief physical and chemical characteristics. The time at my disposal does not permit my giving the detailed account of these questions, interesting and important as they undoubtedly are, but I venture in to call attention to the fact that besides the great importance always adherent to the proving of the existence of a new element, this is one of special interest owing to the purely physical investigation on which it is based. Investigations which, embracing not only nitrogen, several other important gases, are characterized by a delicacy and precision that is fairly met in the history of physical research. Considering also that the discovery of argon we may trace one of the causes of Sir William Ramsay's brilliant discovery of helium and the other so-called noble gases, which followed shortly after, we may truly aver that Rayleigh is that of fundamental character, that the award of him to the Nobel Prize in Physics must be greeted with sincere and fully justified satisfaction, more especially since this section of this work is but a single link in a long chain of remarkable investigations with which, from various points of view, he has enriched physical science and which are of such a nature that they will ensure him a prominent position in its history for all time to come. This is from the award ceremony speech. If you want to read the complete speech, this is a summary. You can follow the link, which is also in the description of the video. And here you see some sample of the metal cesium, which is kept under argon to avoid reaction with argon, and is a noble gas which almost has no reactions with other elements. Well, in the next video, which will be posted in a week, we will go to the Nobel Prize lecture given by the laureate himself. Thank you for watching, and maybe till another time.